Lead, it's one of the oldest materials known to man. It's left its mark on empires and continues to be a vital resource today. Though it's a deadly poison we can't live with, at the same time, it's an essential element we can't live without. And while you probably think this rock doesn't play a huge role in your life, get ready to find out how different your world would be if it weren't for lead on How Stuff Works. Lead. It's a strange substance found in the earth with powers and abilities far beyond those of other materials. It is the speeding bullet, and it powers the locomotive. Able to keep tall buildings from a single sway. That's right, lead is the stuff Superman can't see through, and radiation can't get through. Practically indestructible and remarkably recyclable. While you've probably never thought about it before, if it weren't for lead, your modern way of life would be very different. Believe it or not, the average American uses 11 pounds of lead each year. Because lead is a crucial component in a mind-boggling list of products and applications. So what makes this rock such an MVP? It has to do with its amazing array of properties. For example, this metal can protect itself. Lead has a lustrous silver blue appearance, but when it is exposed to moist air, it darkens and forms a defensive film of lead oxide to guard it from further oxidation. This resistance to corrosion makes it the perfect material for rechargeable batteries.
Lead is what makes the world go.
Nearly everything that moves gets its juice from a lead-acid battery. Just think about it. Your car, a farmer's tractor, even a ballistic missile submarine. And when we need emergency backup power, lead-acid batteries provide that energy as well. In hospitals, air traffic control towers, even the signals at railroad crossings.
Lead's got a lot of properties that make it easy for people to work with.
Lead is soft and highly malleable. That means it's easy to shape because it won't crack or shatter. Why? Because lead has delocalized or uncontained electrons that allow lead atoms to easily slide past one another. Lead is the heaviest member of the carbon family. It has the highest atomic weight, meaning more neutrons and protons than any of the other non-radioactive elements.
Lead atoms are huge compared to all other atoms, and therefore they absorb electromagnetic energy like gamma rays or like X-rays.
This helps lead be the best shield for all types of radiation. So now you know why a certain man of steel had those vision problems. More than 1,000 feet underground. The roar of monstrous machines echoes in the extreme darkness.
Got a haul truck coming through. That's a 40-ton haul truck right there. We've got 3 of those in the fleet and one 60-ton.
Here, deep below the surface of the Earth, men mine lead in an environment most would consider risky. Of all the places on Earth, you might be surprised to learn where lead is being mined on the grandest of scales. Here, under the forested hills of the Ozarks in southeastern Missouri, are some of the highest concentrations of lead metal on the planet. The Doe Run Company operates 6 mines and 4 mills, making it the largest integrated lead producer in the Western Hemisphere. More than 210,000 metric tons of primary lead metal is extracted from these hills each year. The ore runs along an underground strip about 40 miles long, called the viburnum trend.
The ore zone varies in width from, oh gosh, maybe only this wide in some cases. In other cases, it can be a quarter of a mile wide. Just as a core from a hole in this particular environment may only be that thick. However, there are places in the mines here where we have 150 feet of mineralization of a similar nature.
So how far down do you have to go to get to where the lead is? You have to travel as deep into the ground as the Empire State Building is tall.
Right now we're being lowered about 1,000 feet underground. Cage moves about 930 feet per minute.
The man hoist, as miners call the 18 by 14 foot caged elevator, is the primary way in or out of the mine. All of the mining equipment and vehicles must be brought down the shaft in pieces and reassembled underground. This is the Brushy Creek Mine, located roughly in the middle of the viburnum trend. A large work area fills a cavernous section that has been depleted of lead ore. Approximately 2.5 dozen miners are underground at any one time, 7 days a week. The Occupational Safety and Health Administration, OSHA, has developed rules for monitoring for lead in the workplace. All miners are routinely screened to protect them from lead poisoning, even though lead ore is relatively inert and not easily absorbed into the body. This gigantic hollow room was once a vein of lead-bearing ore. The ore was extracted, and the large pillars or columns on the sides were left to support the mine's roof. As ore is dug out, a grid-like pattern of rooms and pillars are left behind. This allows for smooth, flat floors and permits a higher rate of ore recovery.
We get about 75 to 80% extraction. The other 20% is left in the pillars. We mine all the ore in the room part. When all the deposit is mined out, we come back and we actually extract the pillars at the end of the mine life.
And there are different levels to the mine. Like floors in a skyscraper, this permits the same work to be done at different places in the mine at the same time.
The rock has to be broken to extract it, and to do that, you have to drill holes in it to get it to break.
A drill operator can drill about 200 holes in a 10-hour shift.
Basically use water with the drill to control dust and to flush the hole out as we're drilling.
About 3/4 of a mile away from the drilling, an area called 27 Back is being prepared for blasting. A pneumatic hose packs pre-drilled holes with the powerful explosive ANFO. That's an acronym for ammonium nitrate and fuel oil. But why blast? Why not just dig the lead out? The rock that contains the lead, called ore, is so solid, only a series of very strong explosions can break it. After a blast, this is the treasure, chunks of galena ore. Galena is the natural mineral form of the compound lead sulfide. It's the primary lead ore that is mined all over the world. In this natural state, the lead is stable or non-reactive, so it's not extremely toxic.
Basically mine 3 minerals here at this mine, galena, sphalerite, and chalcopyrite. This cubic galena here is about 86% lead, 14% sulfur. That's about as good as it gets right there.
Coming up later, into the hot zone where lead goes molten and becomes a product you can't live without. But first, when we return, did you ever imagine you could wash lead?
how do they pull 1 million kilos of pure white marble from the heart of a mountain?
Seems we've got a little stuck.
How does the world's most versatile construction machine walk out of trouble when it gets stuck in the mud? How do they create the intense flavour of one of the world's favourite condiments? And how do they give tourists the fright of their lives?
Oh gosh, I can't do it.
With a view straight down from one of the world's tallest buildings. We show you how on How Do They Do It?
Lead is considered the father of all metals because we have been working with it for more than 6,000 years. Because of its low melting point, the Romans found lead easy to cast into all kinds of products, which helped make Rome the capital of the ancient world. In fact, the Latin word for lead, plum, is where we get our word plumbing. Lead was also used as a complementary flavoring in Roman wine and food. Yet Romans were aware that lead could pose health problems. The Roman architect Vitruvius cautioned against using it in pipes to conduct drinking water after observing the illnesses plaguing lead foundry workers and miners. And the disease Saturnine gout was prevalent among the Roman aristocrats who imbibed heavily in the lead-laced wine and food. Some historians even blame the fall of the Roman Empire on lead poisoning. Today, we know just ingesting small amounts of lead dust can lead to brain damage and even death. How potent is lead? A child can be poisoned by only 10 milligrams of pure lead. To give you an idea of what a small amount that is, this spoonful contains about 4,000 milligrams. However, those same properties that attracted the Romans made lead popular to many different civilizations throughout history. It's almost impossible to find a portrait of an ancient Egyptian who didn't decorate their eyes with eyeliners made out of ground-up lead ore. And in medieval times, lead was the first choice metal for the movable type of the first printing press in 1455, and was used in lead light and stained glass window frames. Lead ore, also known as galena, has been collected throughout the ages. Galena always breaks in cubes with smooth surfaces because of its unique crystal structure, a property that ushered in a new wireless technology at the turn of the 20th century. It was learned that galena crystals could detect radio signals, and it wasn't long before the favorite wireless device of the time was the galena crystal radio set. Also developed in the 1920s was one of the most significant and damning uses of lead as a fuel additive. It was found that when the extremely poisonous compound, tetraethyl lead, was mixed with cheaply refined gasoline, it stopped premature combustion of the fuel-air mixture in a car's engine. This is known as knocking or pinging. Despite health concerns from the beginning, it took 70 years before leaded gas was completely phased out for use in on-road vehicles. Almost 30,000 tons of lead ore can be taken from the Missouri mines in a day. That's enough to fill a giant cargo ship every 12 hours. But mining is just the beginning of lead's journey. Milling is literally the make and break part of this strategic undertaking that, if not done precisely, can cause millions of dollars in losses from unrecovered lead. But lead doesn't roll alone. This is one element that likes to hang with the crowd. It's up to the Doe Run Company mill in Missouri to separate the lead from the rock and other elements in the ore, such as zinc, copper, and iron.
What we have to do is break the physical bond between the mineral and the host rock, and we do that by running it through the crusher. I like to use the analogy of a walnut. You have to break the shell of the walnut in order to get the sweet meat of the walnut inside. That's what we're doing here. We're breaking that bond so we can get the good sweet lead mineral.
A series of grinders crush the ore into smaller and smaller pieces until it is more like a powder.
At this point, we also add water, and we use water to carry the ore through the rest of the process as a slurry.
What they do now to extract the lead, this heavy metal, is a process you'd probably never imagine. They float it out.
Can you imagine floating lead? Lead is 13 times heavier than water, but we use the chemical and the physical process of flotation to float the lead mineral out of the froth.
They do that by mixing the ore slurry with a number of chemicals similar to those found in laundry detergent. The lead particles then hitch a ride on the bubbles that float to the surface. The foam at the top, which contains the lead, is skimmed off and dried. Left behind is lead concentrate.
I like to use the analogy of an automatic clothes washer. You put your dirty laundry into the washing machine, add a little bit of detergent, and then when you turn the washing machine on, water starts coming in and it fills it up, and you start the agitation. You see suds start to form. These suds actually latch onto the dirt particles on the clothes and float them away. We're using the same process here in the mill, only we're saving the dirt and we're throwing the clothes away. That's where we get the lead out. This is a sample of our final product, lead concentrate. It contains about 80% lead. In this form, it's lead sulfide, which cannot readily be absorbed into the bloodstream.
The next step is removing the sulfur. To do that, the lead concentrate must be trucked to one of Doe Run's smelters. It's loaded into rail cars and sent to the sinter machine. There, the cars are unloaded with a giant tipple. Superheated air roasts the lead concentrate, burning away the sulfur. Then it's hot metal time. At 2,400 degrees Fahrenheit, the blast furnace reduces the sinter material into molten lead. The heavy liquid lead sinks and runs out of a faucet-like tap hole. The melted metal is then put through a series of purification procedures until it is finally poured into molds. The result is what they call 4-9 lead, 99.99% pure metal, ready to be made into countless products and used in thousands of applications around the world. Coming up, one of the most perfect uses of lead. And later, one of the most important.
In 3 years of Grand Am racing, Fall Line Motorsports has never won a race. Team owner Mark Bowden has made a huge investment in doing better this year. New drivers, a new head engineer, and a third car. The quest for speed, measured in miles per hour or fractions of a second. Go too slow and you lose the race.
Pushing his way, bulldozing his way through.
Go too fast and you'll never race again. Speed comes down to physics, chemistry, engineering, physical and psychological conditioning. You can't be the fastest until you master the science of speed.
Since the first firearms, bullets have been made of lead.
Lead is extremely easy to work with, and that's why it's been made into bullets for hundreds of years.
For centuries, bullets have done their job by inflicting damage on impact relative to their size and velocity. In the tranquil countryside of central Missouri, this centuries-old trade continues in one of the most advanced manufacturing facilities in the country. Sierra Bullets makes 160 different designs and turns out between 600,000 and 1 million small arm projectiles each day. These bullets are a far cry from the first simple lead balls. Today, bullets must be balanced for precise accuracy at very high velocities.
You take a bullet and you fire it from a modern firearm, you may be spinning at 300,000 RPM or more at 3,000 feet per second, leaving the muzzle.
Lead is literally at the core of bullet making. The modern bullet consists of a jacket made of a harder metal, such as a copper alloy. This protects the softer lead inside during its launch and in flight, because you want the bullet to be in one piece when it hits the target.
I believe the most important property for lead is the property of ductility. It allows us to deform the bullet permanently, deform the lead permanently into the shape and volume that we desire.
Every 3 minutes at Sierra, an 80-pound bar of lead, called a billet, is loaded into a hydraulic press. Using 250 tons of extremely high pressure, not heat, the lead is pressed through a device called a die, forcing the soft metal to deform into a thin wire. The lead wire is taken up on reels and ultimately cut up to become the core of the bullet.
If we're going to make a very large caliber bullet, such as a .45 caliber bullet, we will use a very thick lead wire. If we're going to make a very small bullet, such as a .20 caliber bullet, we'll use a very thin lead wire. The denser the bullet, the more it's going to buck your wind, the more it's going to negate the forces of wind and continue to travel in a gyroscopically stable manner.
For these projectiles, copper alloy is used for the bullet's jacket because copper is easy to form, but it is hard enough to preserve the lead core when the bullet is fired. After the copper jackets are drawn, they're lubricated with soap and trimmed. Then they are ready to be assembled with the lead core.
When we put a lead core in a jacket, we want it to be able to press to the inside of the jacket and fit perfectly and not shrink back.
If the lead were to shrink in the copper jacket, it would leave an air pocket, and any variance in weight can unbalance a bullet, making it inaccurate. Consistency equals precision, and that's all important in bullet making because the end game is performance.
The most important thing we do here at Sierra Bullets is accuracy.
And that accuracy begins and ends with lead. What do a car, a forklift, and an operating room have in common? Answer: each one is reliant on power from a lead-acid battery. It's the most important use of lead today.
If there were no lead-acid batteries tomorrow, if something were to occur and we wake up tomorrow and there's not a battery in the marketplace, okay, we ride horses or we ride bicycles or we walk. I mean, lead drives the world. It's just that simple.
At Superior Battery Manufacturing Company in Russell Springs, Kentucky, more than 1.5 million lead-acid batteries are made each year. It's a process that involves lead at almost every step.
Lead has several properties that makes it useful for battery manufacturing. It is a soft metal that's very conductive. It's malleable with a melting point of 621 degrees Fahrenheit. It's a stable element and it does well in acid solutions.
Inside this space-age looking contraption, lead is being turned into a very poisonous but very important battery component. 2,000-pound pure lead ingots are melted, stirred, and atomized into small droplets that are then combined with oxygen to form the highly reactive compound, lead oxide. In this line of work, respirators must be worn to keep from breathing any of the tiny toxic oxide particles that can damage the functions of virtually every organ in the body.
It's swirling around in there. When it hits a certain spot in there, it reacts, and that's what makes the oxide. Looks like real fine ground up dirt.
Lead can be melted easily, shaped and cooled quickly without fracturing. This makes it perfect for the grids that go inside a battery. Once charged, a lead-acid battery stores the energy in a chemical form that can be released on demand as electricity. A car's 12-volt battery is composed of 6 2-volt cells. Each cell contains a positively charged plate or electrode made from lead and a negatively charged one. Both are submerged in an electrolyte solution of sulfuric acid and water. Starting the ignition causes the acid to react with the lead, creating an electrochemical reaction that produces a current that generates the power to start your car. Anywhere from 90 to 100 grids must fit flawlessly inside a battery. Remember the lead oxide powder? It's now made into a paste and pressed into the holes of the grids. This forms the battery plate. Inside the flash dryer, a percentage of moisture is removed from the plates with super hot air. Robots then take over stacking the finished plates. And it's a good thing, because the lead makes the plates heavy. A pallet of plates weighs over 5,000 pounds each. Finally, the batteries are off on a conveyor belt to be filled with acid and charged. Each one containing close to 20 pounds of lead. Still ahead, in search of the next big lead strike.
This is the treasure that we're looking for.
And turning garbage into gold. But coming up first, the deadly dangers of lead.
This is the amount that it would take to poison 12 households.
To stay alive, the human body needs a diet rich in items found not on a dinner table, but on the periodic table. Essentials such as calcium for bones, teeth, and muscle contraction, iron to transport oxygen, and zinc for growth and nerve functions. However, number 82, lead, is definitely one element that is not on the menu. Even tiny amounts can have severe health effects on people and other animals. And to make it worse, lead tricks your body to get in. Lead mimics the good elements your body needs, like calcium and zinc. Once inside, it replaces those metals, destroying important bodily functions.
You can think of it as sort of the lead hijacking your body system that it's developed to take up the metals that you need for good nutritional purposes.
By either breathing it or swallowing it, lead typically enters the body as dust. Since it masquerades as a needed mineral, the body readily accepts this deceptive toxin and sends it into the bloodstream. Lead poisoning can affect almost all parts of the body, but its effects are most pronounced in the central nervous system and brain. Here at the Department of Environmental Health Sciences at UCLA, research is showing that lead can take the place of zinc in a protein that regulates how your genes are transcribed or copied. And when this happens, it can interfere with the development of your nervous system and even red blood cells. Lead is one of the most studied toxic substances, and as a result, more is known about the adverse health effects of lead and how to prevent them than virtually any other chemical. Yet according to the U.S. Centers for Disease Control and Prevention, more than 400,000 children suffer from lead poisoning each year. The majority of cases are from swallowing lead paint or playing in contaminated soil around their homes. But why would a kid eat lead paint? It's another tricky trait of this heavy metal. Lead stimulates the specific taste buds that tell the brain something is sweet, making a lead paint chip a tasty yet toxic treat for a toddler.
When children are exposed to even relatively small amounts of lead, they can end up having permanent developmental problems. And certainly if you have very high levels, children could experience coma or even death.
Children are much more susceptible to lead poisoning than adults because a child's body will absorb more lead, and it will retain what it absorbs. This buildup of lead in the body is what causes serious and irreversible damage. In Southern California, like much of the rest of the country, hundreds of thousands of homes were built before lead paint was banned in 1978. In fact, the U.S. Department of Housing and Urban Development estimates more than 38 million homes still contain lead paint, and that 1 in 4 American houses contain some type of lead hazard. And why was lead used in paint in the first place? Because it made paint moisture-proof and durable. The City of Los Angeles is required by law to send inspectors to every rental unit in a multifamily building to look for code violations, including peeling paint.
They find the oldest housing, the largest buildings, places where we know there will be a higher risk.
To confirm the presence of lead in paint, a special lead inspector will systematically go through the home, room by room, testing samples of the painted surfaces. This is done using a handheld X-ray fluorescence device called an XRF gun. It finds lead by reading the unique set of characteristic fluorescence X-rays that lead emits. It's like a detective finding lead's fingerprint at the scene.
We'll test the sash first. 8.2 milligrams per square centimeter. So that's considered to have lead. It's way above the 0.7 milligrams per square centimeter here in LA County.
The areas most likely to have lead-based paint are going to be windows and doors.
It was actually a pretty high reading.
And you want to be careful because those are friction surfaces. So they're rubbing together all the time. They're doing a lot of work that's causing paint chips to come down or lead dust to be created.
Before 1978, lead paint was found inside a home, mostly in 2 rooms where moisture was most likely to be prevalent: in bathrooms and kitchens, on doors and windows.
Some of the areas that you want to be careful with is when you've painted over the hinges, if that's old lead-based paint on there. Obviously on the low cabinets, what concerns me is I see chipping paint around all of them kind of at this height, which is where if you're fixing food in the kitchen and the baby's crawling around, this is a perfectly accessible height.
However, be warned, extensive lead hazard repairs need to be done according to strict lead-safe work practices. The cure can be worse than the disease.
This is the amount that it would take to poison 12 households. So if you think about it, your last remodeling job, your last do-it-yourselfer, did you generate this much dust? And in fact, the reason lead-based paint was even banned in the United States in 1978 was because you had folks doing these repairs themselves and their children seizured and ended up in the hospital. Containment. You want to set up plastic because you want to make sure that any dust or clumps of paint or paint chips are going to fall onto something that you can then clean up, wrap up, and take out of the home. You also want to work wet. You want to be able to not create dry dust that blows around.
Just remember, when removing lead paint, the last thing you want to do is let the chips fall where they may. When How Stuff Works returns, how much lead do we have left?
Eventually, it'll run out.
The dwindling resource we can't live without. And America's secret to a sustainable lead supply.
Good evening. Local Weather Center is calling for another clear night. Another great chance to catch a glimpse of the comet Hale-Bopp, Jen.
Yep, keep an eye for a small bright light with a long tail.
I heard it's going to be northwest. Don't miss it.
Hey, Dad? Look up there. That's not the Hale-Bopp, is it?
A million UFO sightings are reported each year. Most can be debunked, but 5% remain unexplained. These are the close encounters.
Towering above the Sonora Desert, about 25 miles from Tucson, stands the headframe of the San Javier Mining Laboratory of the University of Arizona. Here, future mining engineers come for a little lead 101. So in and around all this rock, how do they learn what's lead and what's not? That's the job of Dr. Mary Polton. As head of the Mining and Geological Engineering Department, it's her job to teach students how to read the rock.
One of the nice things about this mine is that we actually have a lot of exposed rock. We get really excited when we see color in rock and when we see faults and fractures in rock. The color tells us that something unusual has happened to the rock. This is lead sulfide. This is the primary lead that gets mined all over the world. This is what lead comes from.
A large diesel air compressor is used to drive much of the mining equipment. It's called pneumatic technology. The air compressor is like a giant bicycle pump that never stops blowing highly pressurized air into special hoses that run down into the mine.
All right, Scott, want to give me some air?
The students get hands-on experience with this 130-pound jackleg drill. The high-pressure air pounds the pile driver down into the rotating bit, drilling it into the rock. When this mine opened in the 1800s, guess how long it took a three-man team to drill one 12-inch deep hole? A full and grueling day. Now it's bored in a matter of minutes.
Because this rock is really fractured, you gotta be careful that if the steel goes in between a fracture kind of wrong, it'll bind and it'll flip the drill around on you. That's fun.
But mines do play out. From the 1870s to the 1950s, some of the best lead in the world was mined here at San Javier. It's all gone now. So what about the world's supply of lead? How much do we have left?
We have about a 20-year reserve base in the world. A little more tenuous is about a 40-year supply of lead. To get us through another 200 years of lead consumption, it might be a stretch.
4, 3, 2, 1.
Worldwide, there are 240 operating lead mines in 60 different countries. The largest producers are China, Australia seen here at the Century Mine in Queensland, the United States, Peru, and Mexico. Right now, every effort is being made to meet the ever-growing demand, especially from the growing economies of developing countries. The sounds of exploration reverberate through the woods of southeastern Missouri. If there was ever a physical manifestation of lead's future, this core drilling rig is it. They call it wildcat work. Going out looking for resources in places where no one's looked before. It's a kind of high-stakes gambling. Americans are consuming more than 3 trillion pounds of lead every year, and the number is only going up.
It is to determine the future of the reserves for the mine, and also it is to possibly establish new areas to find new minerals.
They'll bore 900 feet into the earth, hoping to find their black gold, a new source of lead ore. A diamond-tipped core drill is attached to a series of 20-foot rods that will cut cylindrical samples called cores out of the rock below.
Each hole has a new story to it. No one hole is alike, and that's what makes this very interesting.
The core samples are retrieved with the use of a lifter tube. Then they're put in a tray to be analyzed and cataloged by a geologist.
This is the treasure that we're looking for. This is the ultimate goal of the drilling program. And as you can see in this core, we have hit what we wanted to hit. We picked the right spot to drill, and we found lead. This is good-looking stuff.
In the geology lab, the cores are studied to determine where to mine next.
1.5 inches of lead in a 14-foot run is what we call pay
hole
run.
This is definitely a pay hole. This will be in a lead-acid battery in another 1.5 years or so, right? Right.
Exploration is crucial. Think about it. All those new mini cars may save on gas, but as they grow in popularity worldwide, they'll increase the demand for lead.
As time goes on, it becomes harder and harder to find. Eventually, it'll run out, and these mines will have to shut down. Hopefully by that time, our exploration group has gone out in other areas and found additional new deposits, which is entirely possible, and we're hoping probable.
When we return, the future of lead looks to the old adage, everything old is new again. It's burn time, and the sparks are flying. This is power recycling, to say the least. Do you know what material has the highest recycle rate in the US? Hint, it's not paper or plastic, it's lead.
In the United States, 98% of lead is recycled. That's about 1.2 million tons. That's because lead is easy to recycle.
Boss, Missouri, the home of one of the largest single-site lead recycling facilities in the world. Here at Doe Run's Resource Recycling Division, up to 100 trucks a day unload a treasure trove of diverse lead waste. From lead bricks used at an X-ray facility, to mountains of lead-laced glass from computer monitors and television screens.
You'll have wheel weights such as this come in, where they've rebalanced their tires. You're going to have firing range material come in here that have spent lead bullets in them. We're going to recycle every bit of that.
But the mother lode is lead-acid batteries of all shapes and sizes.
We're going to recycle approximately 250,000 tons of wet batteries, and we're going to produce about 155,000 tons of lead this year alone.
From regular car batteries to huge industrial-strength batteries like these that have to have their steel cases cut open with a welding torch. And their guts pinched out with a large hydraulic arm. In the area known as the battery bunker, old batteries and an ocean of sulfuric acid fill the huge watertight collection area. Without recycling, all of this would be in landfills.
We actually recycle around 14 million batteries a year. If you were to line them all up end to end, that would be 1,500 miles.
A typical automobile battery contains almost 20 pounds of lead, a gallon of sulfuric acid, and 2 pounds of plastic.
Lead being heavy is a great help for recycling batteries. We break all the batteries up into little pieces. The lead will sink to the bottom, and the plastic will float to the top. That's called the hydroseparation technology. It only works for lead.
The different battery components must be handled separately. Each process is monitored and controlled by computers. Two different furnaces melt the reclaimed lead.
Our blast furnace is the world's largest secondary lead blast furnace. We'll produce 150 tons a day of liquid lead from that furnace. The reverb furnace here holds 400 tons of liquid lead. We're tapping 100 tons right now into a 200-ton kettle. That's about 1,400 degrees. It's a heck of a barbecue, absolutely.
The hot liquid lead is pumped into treatment kettles. Impurities such as copper are skimmed off the top of the molten lead because everything floats on top of lead, except uranium. The lead's now ready to be cast.
Below me is our 60-pound inline casting machine.
We cast a variety of different alloys on it. It cools over about 40 feet of a water trough underneath the molds. Then it's ejected at the end of the casting machine and banded up using steel banding.
Each year, the lead from more than 14 million old car batteries and all kinds of other lead waste is given new life. Because of lead's almost indestructible nature, and the process can be done over and over again.
Lead is a very valuable commodity to mankind because of its unique characteristics. There's only one of its type.
It may not be a silver lining, but the future of lead has one very bright and shiny aspect. If most lead used in America is for lead-acid batteries, that's the same lead that can be used over and over again through recycling.
I don't see us running out of lead anytime in the near future. We recycle over 99% in our industry, so we're not dependent upon totally newly mined lead for this. The recycling rate has enabled us to continue yesterday and today and into tomorrow.
Lead, the oldest metal crafted by humanity. It's treacherously poisonous and must be handled with extreme care. But this extraordinary material has been remarkably useful for more than 6 millennia. Today, the amazing properties of this blue-gray element provide the world with products, protection, and power. There is no doubt about it. Modern science has realized the ancient alchemist's dream. Every day, lead is being turned into gold.